Dear student, in this session we start new article junction transistor or in simply transistor. First thing is what is transistor? Transistor is the combination of two words transfer and register, which means that transfer of resistance takes place from input to output section. It is formed by sandwiching one type of extrinsic semiconductor between other two type of extrinsic semiconductor. For example, if we for a sandwich p type between two n, then it is called as npn transistor. And second one is pnp transistor, means n type material is sandwiched between two p type semiconductor. You can see in a diagram here, this p type material is in between two n type material, then it is called as transistor. Similar manner, another PNP transistor also you can see on screen. Transistor having three terminals. First one is emitter, second one is base, and third one is collector. Now how we identify emitter, base and collector? We can identify it based on the size as well as based on the doping level also. Let me discuss first about the size. So if you see the size of this emitter in a diagram, you can see size of the emitter is lesser than the collector, because emitter and collector both can see n-type material. But here the size of this n-type material is less than that is a emitter. And the size of n-type where it is larger, it is collector in NPN transistor. Similar manner for PNP also. Size lesser means emitter and size more means collector. Now, based on doping level, the emitter is heavily doped. The emitter N-type material is heavily doped. Then next one is collector. It is lightly doped, and base is moderately doped. Now here you can see the symbol of NPN transistor and PNP transistor. Now here the difference between NPN and PNP is in NPN transistor, the emitter having arrow here, and that arrow is outward, going out. Then that transistor is NPN. And PNP transistor, emitter having arrow and that arrow is towards the base. Now you can see here the transistor looks like this: emitter, base, collector, three terminals, and here the red dot means the notch of the transistor. Now let me learn the action of transistor. Now for the normal operation of the transistor, you remember one thing here: emitter, base, emitter base junction is forward bias and collector base junction is in reverse bias. So here emitter base forward bias and collector base reverse bias. Now this is emitter. You can see emitter by capital E, collector by C, and base by B. Now let me connect here emitter junction for forward bias and collector is in reverse bias. Now, so this is the N-type material. So we have to connect here negative of the battery, and here it is a p-type. I mean, this is a p-type metal of the base. It is connected to positive of the battery, then emitter base is in forward bias. Similar manner, base collector is in reverse bias. You can see the terminal of the battery. This collector is connected, collector N-type metal is connected to the positive of the battery, and N-type is connected to negative, means this base p-type is connected to negative of the battery, means base collector junction is in reverse bias. Now we have to see the working of this NPN transistor. For that, we have to remember here in N-type, majority charge carriers are electron. So the emitter's function is to emit the majority charge carrier. Means here in NPN transistor, this emitter emit this electron in base. So where this electron recombine with the holes of the base, only 5% electron recombine here, and due to that we get a base current. and remaining 95% are transferred to the collector due to its reverse bias. Reverse bias. Now here, because of this 95% electron, we get collector current here. Means base current we get because of 5% of majority charge carrier, and collector current we get because of 95% of the majority charge carrier. So we can write here emitter current is equal to base current plus collector current. Now you can see here emitter current, base current and collector current in a diagram. So this is the symbol. Similar manner, this diagram, same diagram we can draw by using symbols also. Now here the relation between the current also we can write here. The emitter current is equal to base current plus collector current. So this is the relationship between these three currents. Now we have to start new article, and it is PNP transistor characteristic in common emitter configuration. Let's see the diagram for this transistor characteristic. So emitter base junction we have to connect in forward bias and base collector junction in reverse bias, and here it is a common emitter configuration. So this is a diagram here. So we can change this VBE, we can change, and this is a VBE and this is IB. So this is the input characteristic. So we get input characteristic like this. So for different values of VCB, we get this is a input characteristic. Similar manner, output characteristic for different values of the base current is as shown in figure. This is output characteristic. So here we are connected potential divider. By using that, we can change this VCE, VB, we can change very easily. And we can note down the current, and after plotting a current and this voltage diagram, output voltage diagram, it is output characteristic. Current and input voltage gives us input characteristic diagram. Now next article related to transistor is NPN transistor as an amplifier. So here we have to learn common emitter amplifier. Now let me consider here NPN transistor. This is emitter base collector. Now emitter base junction we have to connect in forward bias, and base collector junction is in reverse bias. So here this is a common emitter configuration. This emitter is common here. Then amplifier means what? Whatever we are given at input, we get more at the output. The strength of that signal is increased. So you can see here this is input and we get a larger output. Means we get amplified output. Amplifier means the device which raises the strength of the signal, input signal, is called as amplifier. Now if I consider IE, IB, IC, they are the currents. Then we can write a formula IE is equal to IB plus IC. So here IC into RL is the potential drop across the load resistance RL. So by using Kirchhoff's law, we can write the relation here. ICE is equal to ECE minus ICRL. Now next article we have to start, and it is a relationship between alpha and beta. Now first thing, what is alpha and what is beta? Now alpha and beta, these are the current gain factors. So what is alpha? So here alpha is equal to IC by IE, and beta is equal to IC by IB. The ratio of collector current to emitter current is alpha and beta is collector current to base current. Now here we know the relation IE is equal to IB plus IC, dividing both side by IC. So we get IE by IC is equal to IB by IC. IC by IC is 1 here. Now here this is, but here alpha is this, beta is this. By using that we get 1 by alpha is equal to 1 by beta plus 1. So this is a relation. By using that, if we find out beta, we get this formula for beta is equal to alpha upon 1 minus alpha. And if you find out alpha by that, we get beta upon 1 plus beta is the formula for